Hi everyone. So we will go on chapter 10, geometry. So this chapter we will study for a point, line, plane, and the angle. So the basic term. So a point, line, and a plane are three basic terms in the geometry. Thus are not given the formal definition, yet we recognize them when we see them. Um, so for the point line or the plane, like when you see it and you will know it for this. So a point line, a line of a set of a point. So for example, we have so that is the line, and we have all the point on the set. So any two distinct point determines the units of a line. So example, we have this point or this point or this point or this point. That is the unit line. Any point or line separate on the line into the three parts. So either one, we have this one, we have this one, so we have another one. So this one is they light up a two and a half point or whatever, like for example, this line. And we get this, we can divide this one two and a half line. So they have one line here and one line in here. The race is the half of the end point. So the rate from here to here, that is the half of an endpoint. That is the rate. And the light segment in between this endpoint, that's the light segment in the between 2 point um include for that. So this one is the light segment. Uh, this is, uh, uh, the line segment, the race, okay, and the line for that. Okay. That's which I say the line AB. So we have the point AB, and this line they go through. Remember the arrow they go forever. So they have a symbol for AB, and make sure on top they have the line with the 2 point in two direction. The race AB, so whatever the AB race, so this one they go more because one side they still go more. So that is the symbol, and the race BA, and they go opposite. Or the segment line. So like you have a point A and the point B, and we connect together. So without the arrow, so that is the rate. So this one is the rate. Remember for all the symbol. So we have all that symbol. So plants. We think the plant is the two dim, uh, dimensions, dimensional surface that is extend in the infinity line in both direction. And any 3 point are not on the same line. Non-collinear point determines the unit plan. For example, point A, point B, and point C. So you see that they do not have the same line at the 3 point. They can even you can connect the line A C or the B C or the A B. That's the unit point. So this, and also we have another plane. Two line is the same plane do not intersect, called a parallel. Remember, two line is not, they call a parallel line. So for example, see this one is the plane, and we have two parallel lines. So AB and CD, that is the parallel line. So they are the parallel lines. So we have the half plane at the line in the plane divides the plane into three parts. So this line is divided in three parts. The line is and the half plane. So this line right here, the cut is two half plane, this one half plane, and this one half plane, or we have this one the whole plane, but the light's in the middle, so we cut in the two half plane. A plane, any line and a point does not underline determines the unit plane that is the intersection of the two distinct non-parallel lines in the line. Like for example, we have this line right here. So we have this one is the plane. So we have this one right here, and so you see that's how they say any line and a point not on the line determines the unit plane. So this one is the unit plane, non-parallel line. So this one is one of the unit plane for that. Two planes do not intersect. We call the parallel lines. So for parallel lines, because they do not intersect. You see this, the plane HGF, this plane right here, or the Y ABE. So this plane's right here. So this one right here and this one right here, they um do not intersect. So they parallel lines. So this plane right here, you see the pink and the blue, that is the parallel lines. Angle. Angle is the union of two rays of the common endpoint denote. So this one, and this one is the angle. So that is the angle. So this one denote by if we have the angle B, this one they call angle B, or we have the angle of A, B, C. You see, this one even you call angle B, or A, B, C, or C, B, A. That's the angle. C, B, A. Just make sure the middle one, that is the angle of or the vertex of the two rays. So this one terminal size and initial size. So the initial size means that we draw the first. And angle. Uh, angle. So we have the angle. Angle is the point common for both rays. The side angle is make the angle. So this one, the size F, there are several rays to the name of this angle. So we have angle ABC, CBA, or B. That's the angle which we already have at first. So the angle we can measure the angle. Use the angle amount of the rotation from initial to determine side. The angle can be measured degrees or radians or radian or gradients. So you see this at a point. So this one initial side, this is the determined side. So right here, that's one right here, right there. So I say that is 50 degrees angle. So that is the 50 degrees angle. And also we have the angle satisfied that decrease the measure. So the right angle is measured 90 degree, acute angle, so less than 90, obtuse angle, that is greater than 90, but less than 180, and the straight angle is the measures of 180, as we can see right here. You see this? This one is right triangle because this rays and this rays, they're perpendiculars or the symbol perpendiculars right here. So we can say this, or this one acute angle. So this angle in the between 0 and 90 degrees, and this one obtuse angle that's bigger than 90, but smaller than 180. So straight angle, that is 180 degrees. So type of angle. at adjust adjacent angle, the angle that have common vertex, common vertex and a common size, but a common inter points. Um, complement angle, we have two angle, complement angle, that's a two angle whose sum measures 90 degrees. Supplement angle, that's also a two angle whose sum is 180 degrees. So complement angle and supplement angle. So we have for example um for complement angle we have uh so this angle, this one, so we have this angle right here. So I can say this one is A, B, C, and D. So you see that's the angle A, no, angle D, A, C, the measurements of angle, plus the measurements of angle C, A, B. This one, they should be 90 degrees. So you see this. And for a cubed angle, a supplement angle. So we have a supplement angle. So this one is supplement angle. Okay. So this one is A, B, C, D. So we have the same thing. Measurements of angle A, C, B plus the measurements of angle B, C, D. So this one equal 180 degrees. So example 3, in the figure, we already see it in the figure that we see the measurements of angle 31. So we have and so we can have this angle. Okay, this angle we have to draw the angle. Let me see. Um, yeah, and then we have complement angle and supplement angle. So the complement angle, so we have angle, angle. So we have all this angle. Okay, so make sure we have all this angle, complement angle. So A is mean the angle ABC and the angle CBD is complement angle determines for the measurements for that. And for B, so we have the angle ABC and the angle CBE, the complement angle determines measurements of the CBE. Oh, right here. So we have this. So this is determines the solution for this. So we have angle B no ABC, the measurements of angle ABC. So this one is 31. So we have and this one, this angle I call it the X. So the angle X, so X plus 31 equal 90. So therefore X equal 59 degrees. So we have the angle, the measurements of the angle CBD as 59 degrees. So this angle right here, 59 degrees. Okay, as we can see it. So determine the complement angle or supplement angle. So we have this angle is the same, right? Uh, hold on. Uh, so I'm missing something in here. Okay. Okay. For this, so we have a term the supplement angle or the determinant angle. So should be this one is incorrect, I think. But it's okay. So this one should be for this. So we see that's the measurements of the CBE. So CBE. So this one is we can have the measurements of CBE, which we can have 90 degrees. So this one is another 90 degrees right here. 90 degrees plus 59 degrees. For this one 59 degrees. So which we have 149 degrees. So this one right here, total. So you have that. Okay. And determine so definitions of when two straight line intersects the non-adjacent angle form the called a vertical angle. The vertical angle are the same measurements. So this one vertical angle and this one and this one and this one and this one, that's a vertical angle. So we have the measurements of the angle 2 is the same. The measurements of angle 4 and the measurements of angle 1 equal the measurements of angle 3. So this one vertical angle. Okay. So we have the line, a line that intersects two different lines, that two different points is called transversal. So this one is transversal line. So the line, so this line right here, this line right here, that's a transversal line. But in this one, we have L1 parallel with the L2. So we have a special names for all this. So the special name I can type this in here and we can have this one in here. So let me write out the definition for this for really little bit. So special name are given to the angle formed by a transversal crossing two parallel, two parallel, two parallel line. So we should have this one should be in here. Okay, so that's one. And this one, they have a special name for this. So internal internal angle. So internal angle. So we have the same measurements. Opposite sides is the transversal. We have a measurement or alternate internal triangle. So this angle or this angle, that is they have the same measurements or corresponding angle. So on the same side, or this one, or this one, or this one and this one, or this one and this one. So they have the same measurement. So we have the parallel. So right here, the integral triangle is the same integral, so they have the same measurements. Corresponding angle is the same measurement. Okay, so determine the angle. So in this figure, the line cut the transversal determines from the 1 to 7. So we have a 1 to 7. And for this one, so let me copy this. For the next one. So I will do this. Page. This one. Oh, brother. Okay. So we will see this, right? So we know they have to go from the 1 to 8, the measurements from the 1 to 7. So we have the measurements. Let me see. The measurements of 1 equal measurements of angle 2, measurements of angle 3, measurement of angle 4, measurement of angle 5, measurements of angle 6, measurements of angle 7, measurements of angle 8. So as we know, the measurements of angle 8 is 52 degrees already. So remember, what is that? Vertical, right? So this one vertical angle. So angle 8, they have the same angle 6. So same as the angle 6. So this one of 52 degrees. Okay. So they have another one interval. So this one 52. Okay. And then now we know this one and this one we add up with 180, right? So the angle, so we have the measurements of angle 8 plus the measurements of angle, this one angle, yeah, angle 7 is equal 180. But the measurements of that one already we have 52 and plus the measurements of angle 7 equal 180. So the measurements of 7, so this one is 128. So the measurements of the angle 7 is 128. The so this one 128 and angle 5 there is the vertical angle. So if this one 128, so the 5 should be 128. So 128. And now we can see this and we can alternate in interval angle is the same measurement. So alternate interval same measurement. So right here, so we can see this. So alternate. So that is 7. Is that right? So we have right here. Oh no, alternate. So the 6 and 3. So we know as the angle 6, yes. Yes, we know at the angle 6. This one 6 and 4, not 3. 6 and 4. So the angle 6 and the angle 4. So we know that. So 6, we have what? 52. And then so we have 4. So 4 and the same measurements of 2. So that's a 52. And now we can see this, the alternate angle from, so this one, 6 and 4. So this one alternate 5 and 3. We have 5, yes? Yes, we have 5 already. So 3. So we have 128. And then since we have 3 already, so now we can figure out 1 because that's a vertical angle. So 1 is 128. Is that we complete? Yes. So are we done for that? So thank you. So thank you very much.